Question 2, we've got an interest-free loan taken out. The total value of the loan was £8,100, and he repays this in the following way: 400 in the first month, 390, 380, and so on for subsequent months. And you can see this is going to form an arithmetic sequence. And we've got to show that in month 12 he repays £290. Well, you could do this on your fingers, but I think you wouldn't get even the 1 mark involved here. We've got to treat this as an arithmetic sequence and work out the answer. I suppose the danger here is that 8100 is not the initial value of the arithmetic sequence, but 400 is. And I've set out here the sequence: 400 month 1, 390, 380, 370, that's month 4, and below it I've written an arithmetic sequence in its general terms. This is A plus D, A plus 2D, and the general expression for any term in that sequence, A plus n minus 1D. Well, from that it's fairly easy to say that A is equal to 400 and D is equal to minus 10. So the nth term becomes 400 minus 10 multiplied by n minus 1. So to answer part A, all we've got to do is substitute n is equal to 12, and therefore the amount involved is 400 minus 10 multiplied by 11. And if you work that out, that does indeed come to £290. And the answer to part A. Now part B involves sums. We've been told that the nth payment, the loan is completely paid back. So we're going to have to find the sum and prove that this quadratic is true. Well, the sum involved will be 8,100 quid. And this must equal the sum of an arithmetic sequence of n terms. And that's the formula for such a sum. So what we've got to do is put in our values for a and d and set up the equation for n. So this is equal to n over 2. 2a is 800 plus n minus 1 multiplied by negative 10. And remember, this equals 8,100. So therefore I can say, let's multiply across by 2. I can take a 10 out of this bracket, so this is 10n, so this will be 80 minus n minus 1. So therefore, dividing both sides by 10, I get 1620 is equal to n, 81 minus n. So therefore you can see that we're forming the equation we need. This is 1620 is equal to 81n minus n squared. And if we rearrange our terms, we will indeed get the same quadratic that the question suggests: n squared minus 81n plus 1620 is equal to 0. The end of part B. And part C, we've simply got to solve the quadratic. And if you factorise this, you will get this. So therefore n is equal to 36, or n is equal to 45. Well, if he's paying back this loan, the first instance of n equaling 36 must be the point where the loan is fully paid off. So I've said that yes, it must be the first value, and n equals 36 when the loan is paid off. And that's the answer to part C and the end of the question.